Hello student, in this video we will be learning about FM receiver. Now in this topic we are going to be discussing about the FM receiver. Like even for FM also what we are using? Super heterodyne receiver only. For AM also super heterodyne receiver. But what is the main drawback? Main differences? Demodulators and little bit more blocks will come in the FM receiver. Whereas in AM receiver, demodulator is envelope detector. Here the difference will be there. Of course, PLL circuit we are using. So any receiver, the starting block will be the receiving antenna. Now whenever we are designing this receiving antenna for FM, it should be able to receive all the possible signals. Where to where? The FM broadcasting range. FM broadcasting range is from 88 mega to and so on up to 108 mega. This is the total frequency range. So whenever we are designing FM receiver that should be able to work in the range of 88 to 108 because that is the total FM range. After that, after the receiving antenna, what is the next block we are having? We are having multi-stage RF amplifier. Here this multi-stage RF amplifiers are to amplify each and every possible signal. And one more important thing is, students, here in FM receiver, there is no problem of image frequencies. Why there is no problem of image frequencies are here? See, what is the gap between desired and image frequency? What is the gap between desired and image frequency? Desired frequency is Fs and image frequency is Fsi. The gap is 2 IF. Now here IF value we are selected in such a manner that images are coming outside the ranges. Let's see. 2 into 10.7 because IF value 10.7. 2 into 10.7 means 21.4. So the gap between Fs, Fsi is 21.4. If I take Fs value, starting value 88, then where is the image comes? 88 plus 21.4. So 109.4. But our tuning range only up to 108. Even if you take 108 minus 21.4, it's 87 something will come. 86 point something will come. So IF value we are selected in such a manner that the images are coming outside the tuning ranges. So there is no problem of image frequency here. So these RF amplifiers to amplify the signals, all possible signals. After that, as usual, same process, we are having a mixer block. Mixers are used for conversion of frequencies. Another one will comes from the local oscillator, that is FL. Always will maintain FL value greater than Fs for better capacitor tuning. What is that point? I will explain you later. Always in the mixer, down conversion. Down conversion means FL minus Fs, which is equal to IF. Are you getting my point or not? What is this IF values are? Here 10.7 megahertz. By using this FL, what is happening, sir? Tuning will be done. Means whatever may be the channel, if you want to listen, we are changing FL value. Are you getting my point? We are changing FL value corresponding to that. All channels we are bringing to 10.7, not kilo, 10.7 megahertz. So we are bringing to that particular value. After that, what we are having? We are having IF amplifier, where in the IF amplifier selection will be there. This is acting as a tuned section. Here the selection process will be there. Where this is exactly designed, here the selection. Where it is exactly designed, this is exactly designed at 10.7. FR value is 10.7 megahertz. This is gain. Gain versus frequency characteristics. It will be like that. And what is the bandwidth we are maintaining, sir? Bandwidth is 200K. Of course, in that one, 20 will be the guard band. These are the fixed characteristics. So no problem of selection, we already know. After the selection, generally in the AM, we are going for demodulator. But here demodulator, we are having a limiter circuit, of course called amplitude limiter. Double-ended clipper circuit we are using. What is this amplitude limiter is? Generally noise will affect the amplitude. So if any variations in the amplitude of FM signal, the total will be clipped off. Even if you clip off also, no problem, because in FM signal, there is no information in the amplitude of the signal. So any variations amplitude, we can clip off. So most of the noise will be gone here. Next we are giving to the demodulator. What is the demodulator we are using for FM phase locked loop? After the PLL, next we are, before going to the audio and power amplifiers, here is another block about this I will explain you, that is called de-emphasis. And in the transmitter side, another thing also will do, that is called pre-emphasis. About de-emphasis and pre-emphasis I will explain you. Wait. After this, we are increasing the audio levels, common emitter configuration we are using, as well as to increase the power levels, power amplifier. I already told, class B power amplifier. Audio amplifier means voltage amplifier, current amplifier. So obviously power will increase. Next will be the loudspeaker, which will convert this electrical signal into physical phenomenon. This is the block diagram of a FM receiver. When compared to AM receiver, what is the additional blocks, sir? Amplitude limiter and de-emphasis, sir. Because of this amplitude limiter, most of the noise will be gone. So figure of merit of a FM is very, very high. I already given generally 37.5, in AM only 1/3, maximum itself, that is 0.33. That values also I shown. I given in the previously. So what is the de-emphasis, sir, and what is the pre-emphasis, sir? Try to understand. This concept of pre-emphasis and de-emphasis came, see. In FM radio, from where to where we are transmitting the signal in audio signal, 50 to 15 kilo. In AM, maximum itself is 5 kilo. In AM, these concepts are not needed, but in FM need. Why? Because practically if you see, the power spectral density, PSD of audio signal, as well as if you see the PSD of noise signal. PSD means power spectral density. Power spectral density. Power spectral density means just you can feel that power versus frequency graph. Power versus frequency graph. So if I draw for them, frequency versus gain, frequency versus power spectral density. So if I draw the frequency versus power of audio signal as well as noise signal also, what is its graph is actually, as the frequency value increasing, the strength of the components will be decreases. This is the signal power. But in the coming to the noise, as the frequency increases, noise power also increases. Noise power I am denoting with N. Let's take some value, for example F1. Here also the same value, for example F1. By seeing the graph itself, you can understand up to F1, signal to noise ratio is greater than 1 only. But after signal to noise ratio is less than 1. You can see the graphs. Are you understand my point? So up to F1, signal to noise ratio greater than 1 means we can reconstruct our signal back. But after F1, the signal to noise ratio, if you observe there, is less than 1. Less than 1 means after this, we are unable to reconstruct the frequency components. Are you getting my point? So here there is another word also called, that is called fidelity, students. There is another word also called, that is fidelity. What is the meaning of fidelity is, it is a capability of a radio receiver. It is a capability of a radio receiver to produce all the input frequencies at the output of a receiver also. But what is happening here is, students, because of, what is its F1 value? I will tell you practically. Because of this is a practicality. Because of the here, up to F1 S by N value greater than 1. Greater than 1 means we can reconstruct our signal because signal strength is more. But after F1, we cannot because signal strength is less. Just like if my voice strength is more when compared to all other external disturbances in your room, then you can be able to listen what I am saying. Understanding or not is a different issue, but you will definitely listen what I am saying. Like here also, if the signal strength means my voice, if that is more, you can able to listen. If external disturbance is more, you cannot listen what I am saying. Like if signal to noise ratio more means greater than 1 or far greater than 1, we can reconstruct the signal. Less than 1 means we cannot. So here in FM, it is suffering from the fidelity. Fidelity is saying that you need to reconstruct all frequency components what you are transmitting at the input section. Of course, at the input section, we are transmitting up to 15 kilo. Are you getting my point around? F1 value is around some 3 kHz. Some 2800 something is their practical value. So, but after 3000, signal to noise ratio is decreasing. We are unable to make it. So that's why what we are doing is, we are going for a pre-emphasis at the transmitter and we are going for a corresponding de-emphasis at the receiver. What is a pre-emphasis, sir? Pre-emphasis means to reconstruct these higher frequency components or to improve the signal to noise ratio of these higher frequency components. To improve the signal to noise ratio of these higher frequency components, we are artificially boosting the higher frequency components. That artificial boosting of higher frequency components itself is called, students, pre-emphasis. Are you getting my point? Artificial boosting of these higher frequency components to improve signal to noise ratio is itself is called pre-emphasis. Where we are doing pre-emphasis, sir? Pre-emphasis will be done at the transmitter side, sir. Before modulation, sir. Before modulation, we are doing the pre-emphasis. Are you getting my point? Practical value some 2800 Hz or 2.8 kilo. Around 3 kHz you can say that. So what we are doing, these we are artificially boosting. This will be done. Pre-emphasis will be done. Pre-emphasis will be done where, sir? At the transmitter, sir. Transmitter before modulation, sir. Before modulation, we are doing the pre-emphasis. What is the circuit we are using for pre-emphasis is high-pass filter, or you can say lead compensator. Phase lead compensator we are using, sir. If you want the circuit diagram of that, how that phase lead compensator? This is a circuit diagram of a phase lead compensator, sir. How that diagram, how that characteristics will be there? Its characteristics is, if you take gain versus frequency characteristics, we take the gain versus frequency characteristics up to what is the desired frequency, it is constant. Later its slope is increases. This value I will maintain as a f1. Up to there it will maintain a constant gain of 1. That is a phase compensator. Now what is de-emphasis, sir? De-emphasis will be done at the receiver after demodulation, sir. After demodulation. What is the circuit we are using for de-emphasis, sir? Will be the low pass filter, sir. So what is the de-emphasis characteristics? If I write gain versus frequency characteristics of a low pass filter or de-emphasis circuit, we here also up to f1 will maintain constant gain after the slope is decreases. Here the slope of that decreasing one, here the slope of this increasing one will maintain both are same. If you are maintaining both are same means exactly we can get back our original signal. So here three terms I discussed. One is fidelity, another is called pre-emphasis, de-emphasis. Fidelity means it is a capability of a radio receiver to produce all input frequencies at the output of the receiver also. FM is suffering because of the signal to noise ratio is less. So what we are doing before the modulation itself in the transmitter, we are artificially boosting and we are increasing the signal to noise ratio. Then obviously we can reconstruct them at the receiver. So how much we are boosting, that itself is called pre-emphasis. The same amount of boosting will be decreases, that is called de-emphasis after the demodulation, sir. This is developed by the Dolby company. This pre-emphasis and de-emphasis. Because of that, the audio signal or the music quality will be excellent. Because we are able to produce all the frequency components. See the next problem on the FM receiver. A superheterodyne FM receiver operates in the frequency range 88 to 108 mega. The IF and local oscillator frequencies are related FIF less than FLO. We require that image frequency fall outside the range 88 to 108, means outside the tuning range. First question, the minimum required FIF is, he given some options. Second question, the range of variation, the local oscillator. It's a simple one, I am not giving the options. Anyhow, what is saying that you need to calculate FIF in such a manner that the images has to come outside the tuning range. Means, what is the range, sir? Is operating from where to where, sir? 88 mega to 108 mega, sir. 88 to 108 mega, sir. Now follow. For example, if I take Fs value is 88, for example, where is the image has to come, sir? Outside the tuning range, means outside the 108. Or if I take this value is Fs, it has to come before 88. What is the image frequency formula, sir? Fs plus 2IF value greater than or equal to 108 mega, sir. Then Fs value 88 comes this at 20, so 2IF greater than or equal to 20 mega, sir. Then IF value greater than or equal to 10 mega. So then at least its value, minimum value should be 10 mega. That is the answer. Sometimes, here the logic one more time see. 88 to 108 is a practical FM range. So what is the practical value of IF? 10.7. If sometimes in any of the option 10.7 mega is there, choose that. If 10.7 is not there, actually from the mathematical calculation 10 mega. If both are there also, this is the first preference, this is the second preference. Because 88 to 108 is a practical range given. Any other ranges are given, calculate from the mathematics concept only. Here the question is, we need to get the image outside the tuning range. Tuning from 88 to 108. Clear? Then this should be greater than that. If 10.7 is given, consider, because this is a practical range. Any other ranges, for example, 48 to 58, 58 to 68, like different is given, then you can go with the normal mathematical calculations only. Don't bother about that. Clear? Yeah. See the next problem. The range of variation in the local oscillator frequency. Local oscillator frequency means what's the FL value? What is the formula for FL? FL is Fs plus If. Fs is varying from 88 to 108 plus If. If value we got 10. So it will be 98 mega to 108 mega. If practical range is given 98.7 to 108.7. That is about the local oscillator means FL value. Got the clarity? Yeah. See the next problem. It is a accession reason type of question. What is the accession given? Preemphasis is used to amplify high frequencies. S. After F1, to improve the signal to noise ratio, we are artificially boosting. That itself is called preemphasis. So accession is a correct only. And what is de-emphasis? De-emphasis also we are using for same high frequencies, the same proportion to decrement. But see the reason. De-emphasis circuit is used to de-emphasis low frequency components. No. For the same high frequency components we will use. So reason is wrong. Then there is no discussion for correct reason or not. So assertion is correct, reason is wrong. So directly option C. Preemphasis and de-emphasis both we are using for high frequency components only.